current measured by the receiver on a suspected target conductor. If low is flashing alternately with the frequency, the signal path circuit is incomplete or inadequate. The far end return to earth may be missing. Verify that there is a return to earth on the far end of the target conductor and then measure the signal path resistance again. Once a good signal path has been created and the correct frequency applied to the target, the next task is to detect the signal with the receiver. Turn the receiver on by pressing the power button. From the main locate screen, select Cable Pipe. The locate screen will appear on the receiver. Press the first yellow command key labeled Frequency repeatedly until the transmitter frequency is displayed above this key. Press the Locate OK button to return to the locating screen. To select the locating mode or antenna configuration of the receiver, press the second yellow command key labeled Mode. Repeatedly pressing this key will toggle the receiver between directional peak mode, directional null mode, and special peak mode. Most of your locating will be done in the directional peak mode. In directional peak mode, the receiver uses all 4 of its peak antennas to pinpoint the target path. The numerical signal strength in the middle of the locate screen indicates the actual strength of the transmitted signal that is reaching the receiver. The point at which this numerical signal is the highest value indicates the center of the electromagnetic field or the target conductor. The bar graph should open when the receiver is off target path and close when over the target path. If the bar graph is not responding to the target conductor, adjust the gain by pressing the gain adjust keys. In addition to the signal strength and the bar graph, the audio response of the unit will increase as you get closer to the target path. In directional peak mode, the receiver's middle crossbar detects the rise and fall of the electromagnetic field surrounding the target facility. This crossbar contains the antennas that operate the directional arrows. As the receiver approaches the electromagnetic field from the left of the target path, an arrow will appear on the locating screen pointing toward the right. It is detecting the rise of the electromagnetic field surrounding the target conductor. As the receiver crosses the path of the target conductor, the arrow pointing to the left will appear, indicating the target has been passed. The crossbar is now detecting the fall of the electromagnetic field. When the crossbar is centered over the electromagnetic field, both arrows will appear. The numerical signal level should be at its highest value, the bar graph should be almost closed, and both arrows displayed when locating a target with an undistorted electromagnetic field. To verify the target path, measure the depth to the conductor. Place the tip of the receiver on the ground and press the yellow command key labeled Depth. The depth of the conductor will appear on the left-hand side of the screen. It should be the value that you are expecting to see when locating this particular utility. On the right-hand side of the screen, the relative current of the conductor will appear. If you are locating a single conductor using the direct connect method and are on the target, this value should be very close to the relative current that is flashing on the transmitter. You can save this depth and current reading along with 4 others for future reference. Simply press the Save Command button while in the depth screen. To return to the locate screen and continue marking the target path, press the Locate button. This concludes basic locating with the 3M Dynatel 2273 MID Ultra Advanced Cable, Pipe, and Fault Locator. This chapter will cover a quick review of fault locating with the 3M Dynatel 2273 MID. In order to pinpoint a fault, it is necessary to isolate the faulted section of the cable at both ends. Connect the red lead of the transmitter to the faulted conductor, and the black lead to the ground rod that you have placed in line with the suspected cable path. Check the battery level of your transmitter by holding down the off key. Measure the severity of the fault by pressing the second button or ohm key. Place the transmitter in fault mode by pressing the second key again. A flag will appear on the display under the fault icon, indicating that you are in fault mode. Step back to the ground rod, place the A-frame a width away from the ground rod and slightly forward to take a reference reading of the fault signal at the ground rod. Press the yellow reference key to save this reading. The arrow on the receiver screen will indicate which leg of the A-frame is closer to the fault. Continue fault locating, reinserting the A-frame probes while watching the receiver bar graphs. The bar graph on the receiver will fill toward the green band on the right side of the screen, indicating that the fault is ahead of you in the direction of the green banded leg of the A-frame. When the bar graph fills toward the red band on the left side of the screen, the fault has been passed and is now behind you. Move back, inserting the A-frame every few inches until the arrows alternate back to green. Mark the point beneath the center of the frame. Turn the A-frame 90 degrees and insert it into the ground over the previously marked point. Move the A-frame to the left and right, following the directions of the green and red indicators on the receiver. When the arrows reverse, turn the A-frame 90 degrees again. Pinpoint the fault by moving the A-frame in the direction of the green and red arrows. The fault is located beneath the center of the frame when the arrows change from one side to the other this final time. To verify the fault location, insert the frame's red probe directly on the spot identified. Pivot the A-frame in a circle around the red leg, reinserting the green leg in the ground every few degrees of the circle. The arrow should always point toward the red band on the left side of the screen, indicating that the fault is directly below the red leg. After a fault is found and pinpointed, move the A-frame about one frame width away from the fault and insert it in the ground with the green banded leg towards the fault. Compare the signal level on the receiver screen with the fault level reference indicated in the lower left box labeled Reference. If the reading is within 12 dB of the reference, the operator has found the major fault. This completes the quick review of fault locating with the Dynatel 2273 MID. This chapter will provide the basic principles and a guide to fault locating with the 3M Dynatel 2273 MID cable, pipe, and fault locator. The 2273 MID fault locator will find earth return faults. An earth return fault is one in which an insulated conductor is physically making contact to the dirt due to some damage that has occurred to the insulation of that conductor. When fault locating, the first step is to isolate both ends of the faulted section of cable. There should be no physical connection on either end of the cable.
When fault locating, the transmitter is connected to one end of the faulted conductor. It sends a signal through the good portion of the conductor. When the signal encounters a fault, the signal returns through the dirt, back to the ground rod, and through the black lead of the transmitter to complete the circuit.
Fault locating is pinpointing the spot at which the transmitted signal leaves the conductor and re-enters the ground. When the transmitted fault signal reaches the fault, the signal radiates from that point, creating a pool of signal around the fault. This pool of signal is referred to as the area of detection. A pool of signal exactly equal to the signal pool around the fault exists at the ground rod. The areas are exactly the same size. The size of these pools is determined by the soil conditions and the severity of the fault. To measure the severity of the fault on this conductor, first ensure that both ends of the faulted conductor are open or isolated from any connection. Connect the red lead of the transmitter to the faulted conductor. Place the ground rod behind the transmitter in line with the suspected path of the conductor. Connect the black lead of the transmitter to the ground rod. Check the battery level of the transmitter by holding down the off key. Press the second button on the transmitter, which is the ohm key. A flag will light in the display above the ohm icon, indicating that the transmitter is in ohms mode. A resistance measurement will appear on the display. The lower the resistance of the fault locating circuit, the more severe the damage is to the insulation of the conductor. If OL appears on the display, this is an indication of an open line. This indicates that there is not an earth return fault on this conductor. Press the second button on the transmitter again to place the transmitter in fault mode. A flag will appear in the top portion of the display below the fault locating icon, and two locating frequencies, 577 and 33 kHz, will flash alternately on the display. We will address the advantage of these locating frequencies later in this video. Connect the 3-foot A-frame cable to the A-frame, making sure the cable is completely seated. Then, plug the A-frame cable into the receiver. It connects to the bottom of the receiver through the 1/4-inch jack. When the spiked points of the A-frame are pressed into the ground, the A-frame becomes a two-dimensional sensor that will detect the fault. The receiver will calculate whether the green banded leg or the red banded leg is closer to the fault. Turn the receiver on by pressing the power key. From the main locate screen, press the command key below the word fault to place the receiver in fault locating mode. The receiver will immediately begin a momentary calibration mode, preparing to fault locate. It doesn't matter whether the A-frame is in the ground or not at this point. When the calibration is complete, step back toward the ground rod. Measure about 1 A-frame distance to the right or left of the ground rod. Step slightly in front of the ground rod and push the A-frame into the soil with the green leg toward the fault. This is the point where you are going to record a reference reading of the fault signal. The numerical value that is displayed on the receiver screen is a number that you should remember. For convenience, you can save this reading by pressing the first yellow command button on the receiver labeled Reference. The reference signal level at the ground rod will appear in the box above this key. Previously, we discussed that the fault pools created around the fault and the ground rod were equal in size. They are also equal in signal strength. When you have pinpointed the fault on the conductor, the signal strength at the fault will be within 12 dB or 12 points of the reference signal you measured at the ground rod. With the A-frame still inserted at the reference point, you will notice on the receiver that an arrow fills the screen toward the green band on the right side of the receiver. This is the indication that the fault is closer to the green leg of the A-frame than to the red leg. Move the A-frame forward toward the green leg, insert it into the ground again. Let the signal settle on the screen, then move the A-frame toward the red or green leg indicated by the receiver. It is not necessary to probe the ground every few feet. Divide the section into pieces and continue probing the ground until the arrow reverses. The receiver now points toward the red band on the left side of the screen, indicating that the red leg is now closer to the fault. Probe the ground back and forth until the fault is centered between the red and green legs of the A-frame. You have now located the fault two-dimensionally. You have centered the A-frame over the fault in the forward and backward position. Now you need to pinpoint the fault in a left-right direction. Turn the A-frame 90 degrees over the center point that you have just pinpointed. Watch the receiver screen for an indication whether the red or green leg is closer to the fault. Probe the ground moving left or right toward the red or green indication on the receiver until the arrows reverse again. Center the A-frame over the fault. Place your toe on the ground at the center point between the two legs of the A-frame. Turn the A-frame 90 degrees one more time to verify the forward and backward location of the fault. When the arrows on the receiver screen balance, the fault is under the center of the A-frame. Verify the fault location by placing the red banded spike into the pinpointed fault location. Insert the green leg into the ground randomly in a 360-degree circle around the fault point. Watch the receiver screen. Every time the green leg is inserted into the ground, the arrow on the receiver will point toward the red band on the left side of the screen, indicating that the red leg is always closer to the fault than the green. After the fault has been found, move the A-frame about 1 frame width away from the fault and insert into the ground with the green leg toward the fault. Note the signal level on the receiver screen. If this is the only fault on the line, or the most severe fault on the line, the numerical signal strength on the receiver screen will measure within 12 dB of the reference reading you took at the ground rod. This reference reading is in the bottom left corner of the screen labeled Reference. If this signal level does not fall within 12 dB of the reference reading, there may be multiple faults on this line. Sometimes you will be fault locating on very long sections or in very bad soil conditions, and the fault signal pools may not overlap each other across the entire section of cable. You must be within one of these pools in order for your equipment to detect the direction to the fault. For example, You have a section of cable that is 100 feet long. There is a break in the insulation of this cable, causing an earth return fault at 55 feet. It is very likely that the areas of detection, or pools, will overlap on this short section of cable. You would never know that you have passed from one area of detection to the other. But if your section of cable is 2,000 feet long, and the fault is at 1,500 feet, the fault signal pools or areas of detection may not overlap. There may be a portion of the cable that is only carrying the fault signal. If this is the case, you may find that the receiver will seem to be confused in the middle of the section or not give you a strong indication of red or green. This only means that you have walked out of one of the fault signal pools and have not yet entered the second. This poolless area is sometimes called a dead zone. For example, if you lose fault indications 500 feet away from the transmitter, you have entered the dead zone. This dead zone will continue until you are within 500 feet of the fault. Then you will begin detecting the fault again because you have entered the fault pool. The transmitter sends two locating frequencies, 577 and 33 kHz, simultaneously with the fault locating signal. These locating frequencies can help you get through the dead zone and stay on the cable path until you get closer to the fault or walk back into the second fault pool. To switch the receiver into cable locate mode from the fault locating mode, press the locate button, then the yellow button under cable pipe. It is not necessary to unplug the A-frame while in the cable locate mode. The cable locate screen will appear. Set the frequency of the receiver to 577 or 33 kHz by pressing the yellow key labeled Frequency until 577 or 33K appears. Typically, 33 kHz will be the locating frequency you will use because of the high resistance of the fault and soil conditions. Press Locate to acknowledge the frequency setting and enter the locating screen. It is easy to switch back to fault locating by pressing the Locate button and pressing the yellow button under Fault. Probe the ground with the A-frame to see if you have re-entered the second fault signal pool. If you have, you will see a steady red or green indication on the receiver's screen. Continue following the indications from the receiver and the A-frame until the fault has been pinpointed as stated earlier in this chapter. This concludes the section Fault Locating with the 3M Dynatel 2273 MID Cable, Pipe, and Fault Locator. This chapter will introduce you to the accessories that are available for use with the 3M Dynatel 2273 MID Cable, Pipe, and Fault Locator. The 3M Dynatel 2273 MID Ultra Advanced Cable, Pipe, and Fault Locator has been fully tested and calibrated at the factory. The calibration document is included with each unit via the RS-232 cable. Included with each locator is a CD that contains copies of the manual and software for your personal computer that allows you to communicate with the receiver via the RS-232 cable. The personal computer software provides the means by which receiver software updates can be field installed. The receiver can be configured to your preference, including an ID marker utility that complements the read-write capability of the M-Series locators. Standard equipment packages include the 2273 MID receiver and the 4-frequency transmitter, the ground rod, the red and black direct connect leads with small communication clips, or larger utility clips. Depending on the package purchased, a 3-inch or a 6-inch coupler and coupler cable may be included. For fault locating, an A-frame and the A-frame cable are included. If you have purchased a 5-watt transmitter, indicated by an input port located by the output jack on the transmitter, a cigarette lighter adapter cord will be included with the unit. Additional accessories that are available include a carrying bag, a ground extension cable, and a rechargeable battery pack that is compatible with the 5-watt transmitter. We also provide a sonde or active duct probe for locating empty conduits and obstructions. The ID portion of the M-Series locators provides the capability to locate all EMS markers, as well as the ability to read and program the 1400 series programmable EMS ID markers. This concludes the Introduction to Equipment and Accessories chapter.